So we are going to conduct the experiment step up and step down MOSFET based chopper. What is chopper means? Chopper will convert variable DC to fixed DC. So fixed DC to variable DC source. Variable DC. We are going to convert fixed DC to variable DC. We have two types of chopper. One is step down chopper and another one is step up chopper. Step up chopper means we are giving the input voltage 10 volt mean it will increase the output voltage more than supply voltage. If you are getting mean that is step up chopper. For in case of step down chopper, the output voltage is less than the supply voltage. It is called step down chopper. So how can I differentiate both the chopper circuit? So here we are using the switching device as MOSFET. So switching device MOSFET, depending upon the situation in the place it is situated, it is said as if it is after comes from the supply inductor, after the next we are getting the switching device means this is MOSFET step up chopper. In case of step down chopper, the MOSFET will be comes next to the supply series to the inductor. So this is why we are differentiating the step up chopper and step down chopper. This is the firing circuit. We are giving the DC supply, we are getting the variable DC supply. It is works on the switching timing. Okay. For this kit, okay, this is the kit for experiment for conducting the step up and step down chopper. Here the MOSFET is placed here. Okay, for this MOSFET we have to give the gate pulse. Whatever the power electronic devices we are using means we have to give the gate pulse, then only it will be turned on. So we have to generate gate pulse circuit here separately we have. So we are PWM output to PWM input. This is one connection. Okay, next feedback. Why we are giving the feedback mean while comparing with the output, the input will be automatically changed. So this is the two connection. This will transfer the gate pulses PWM input and output. This is for feedback. Output lande input kondu poi kudukradha use pandranga seriya. This is the two connection. Next we have to give the DC supply. So we have to get the fixed DC from the RPS. We are using the RPS power supply to give power supply to the circuit. We are giving the power supply. This is input. So we are going to measure the output by using the multimeter. So we have to adjust it to the multimeter. Then we are going to see the waveform. We have to measure the waveform from the CRO. We are using the oscilloscope. So we are going to give the CRO connections. So red positive is connected between the terminals T1. This is the pulse generator circuit we are giving here. We are giving T1 and T5 across the ground. So these are all the connections we are giving. This is the only connections. Okay, wow. Connections, everything is over. Now I am going to turn off the power supply. See what is the result we are going to get. So I have to give 10 volt input. Input is supply voltages we are giving 10 volt. This is 10 volt supply. So what is the output we are getting? 5 volt. So we are given the input is 10 and the output is 5.5 volt. Okay, ma'am? So what is the converter we have? We got the output. Step down chopper. Step down chopper, step up chopper. So now the output is input it is less than 1. Okay, it is a step down chopper. Okay, now I am going to take down the readings. So listen, step down chopper. We are giving the supply voltage 10 volt and the output voltage is 5.3 volt. So now measure the volt output, 5.3 volt output. We can change the duty cycle by varying this firing pulses. So now measure the T on time and T off time. On period, off period. It is two lines is there, 0.4. So T on is 0.4 and T off from the origin to one box. So unit is 1 unit. The multiplying factor for this is 0.1 milliseconds. Common multiplying factor is 0.1 milliseconds. This is for 5 volt output. If I am taking for 8 volt, when changing the pot இந்த MOSFET ஓட டைம் பல்ஸ் சேஞ்ச் ஆகுது. ஸோ டைம் பல்ஸ் சேஞ்ச் ஆகிறதால அவுட்புட் சேஞ்ச் ஆகுது, அவுட்புட் வோல்டேஜ் கண்ட்ரோல் ஆகுது. இதுதான் கான்செப்ட். ஸோ now measure T on is third line, okay, 0.6 and T of position control this one. So this is also in 8, 4 lines are there, okay, 4 lines. This is 1 unit, 0.2, 0.4, 0.6, 0.8, 4th line. Okay, wow. Output voltage is 7.8. We are going to reading for step-up chopper. What I said, while changing the switch position, the chopper will be changes from buck to boost, boost to buck. So just I am going to change the switch from buck mode to boost mode. Okay, buck to boost. If you are changing the buck to boost, then we are getting the output voltage increase. So it is increased. The supply voltage is 10. We are getting the output voltage 27.5 volt. Now the converter is working in boost converter. Now measure the T on and T off. How much T on? No, T on period. 1 unit is 0.2. So T on is 1, 0.2 because here output voltage is increased. So conduction period is also more. Conduction period more ஆகும்போது output voltage more ஆகும். The concept, okay? So now I am reducing this voltage to 20 volt. I am changing the gate pulse. Gate pulse change ஆகிறதால time adjust ஆகுது, time adjust ஆகிறதால output voltage control ஆகுது. இந்த output voltage control பண்ணுறோம் 20 volt. So the on time is 0.8 and the off 0.4. 2 lines, 0.8 and 0.4. Okay, now I am changing to 15 volt. 15 volt output. What is the on time? Third line, 0.6 and the off time is 0.6. 5 something, 0.6 inch. Okay, well, this is the measurement, okay. So we are calculated the values. So these are all the way we can control the output voltage. Why we have to control the output voltage? What are the examples? So we need to control the motors. So motor for speed control பண்றதுக்கு we have to reduce the output voltage. So output voltage reduce பண்ணனா we have to use the switching devices. That's why we are going with the step-up and step-down chopper. These are all the examples, okay.